know about squares?
4 sides.
4 sides. What about the 4 sides? They're equal. Okay, so if we're completing the square, it's because both sides are equal. The length and the width are equal, yes? So this makes a lot of sense when we show y'all tiles, which is why we're going to show y'all tiles. Okay, now are we going to use tiles and make you draw them all the time? No, but it's a good resource to see it, so that way it kind of makes more sense. So here's our square. Is this a perfect square? Yeah, because I have x squared, and then I have, well, technically this is the length of x, correct? Okay, and then I have 3 singles, and then do I have a length of x and 3 singles again? So are they the same? Yeah, so when I say polynomial, I want to know the expression this gives you. So how many x squareds do I have? 1. How many x's do I have? -6. We have -6 x's. And how many singles? 9. So that's the polynomial. And the factors are what would multiply to give you this. So what's my length here? It's an x, right? Remember that long side is the x. This is also an x. But the short side is a single. So I have 1, 2, 3. So I have -3. And then again 1, 2, 3. So I have -3. Well, if I want it to be a square, don't both of those have to be the same? Okay, so I know I have to split my x's in half to keep it a square. Okay, so my factors can be written as x minus 3 times x minus 3. I don't know what I was about to write there. 3. Or, how else could I write that? X minus 3 squared. Because they are the same, we can put it together and call it squared. Well, isn't that kind of the whole point of what we're doing right now? If we want it to be a square, it's because we want it to look like this. Yes? So that's literally our whole goal today, is to make a polynomial turn into a square if it's not already a square. And I will tell you they're not already squares. So we have to turn them into squares. So we're going to kind of talk about it with tiles, and then we're going to take the tiles away. Cool? I say with tiles, we're going to draw them. We're not going to have them. Okay, so looking here. This is our equation. Remember, the solid line is just like your equal sign. So this is just this, right? Are they the same? Yeah. Okay, so I am missing what to complete this square? What do I need to complete that square? The singles. How many singles? 4. Because I know that I'd have to do 1 there, 2, 3, 4. Well, if I add 4 to this side, what do I have to do to that side? Add 4 more. So 1, 2, 3, 4. Well, algebraically, didn't I just add 4 to each side? Yeah, so that's all that we need to put in that blank. Okay, well, what about this side? What is it? Well, I have a length of x, and then I have 2 positive singles, a length of x, and 2 positive singles. So I can write this as x plus 2 squared equals, well, what's 5 plus 4? 9. Any questions of that? That's what completing the square looks like. Okay, and we're not going to solve it all the way. I know it says solution on my paper, but we're not solving it all the way. We're just setting them up. Yes, today. Okay, so looking at number 2, we're not going to solve today. Now, we will solve square root method. Wouldn't you just solve this with the square root method? Square root both sides? Haven't we already learned that? So that's kind of why we're taking it one piece at a time. We're just going to focus on the completing the square side. So looking here, this one is already set up. So I will tell you, the way we want it to be set up is we want our constant, our c of the quadratic equation, to be on the right. Is this one already set up that way? Yeah, so I know when I draw it, I have an x squared, and I have 6 x's, but I want it to be a perfect square, so how many would each side get? 3, yeah. And then I have 7 singles on the other side. 1, 2, 3, 4, 5, 6, 7. Because the other side equaled 7, right? That's why we have that. So, how many singles do I need to complete this square? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I add 9 to this side, what do I have to do to the other side? Add 9. 1, 2, 3, 4. Well, what's 7 plus 9? 16. So this side is 16. And what would this be written as a squared? What's my length here? And how many singles did I put? Plus 3, or how many singles? Okay, and then x plus 3, so this is x plus 3 squared. Okay, I think some of y'all might have the old copies, so some of y'all might have a number here, and I think it's wrong. So just if I write something, make sure yours matches, okay? Okay, so here, again, I have to have my A and B term by themselves. I want my C term on the right, so what would I need to move? The 1. So I'm going to do minus 1 on both sides. And that leaves me x squared minus 4x and a plus something. We're going to have to add something to both sides. And then what does that leave me on the right? 6. So then we're always going to kind of rewrite it with these blanks, which will make more sense when we get to the back. But right now with tiles, it's a little different. So I'm going to draw my x squared. And then how many x's on each side? Yeah, -2. So I'm going to have 1, and I'm just going to kind of shade it. 2, 1, 2. And then on the right side, I have 6, 1. How many singles do I have to add to complete this square? 4. 1, 2, 3, 4. So if I add 4 on that side, 2, 3, I have to add 4 on this side, so algebraically we have to have that plus 4 on both sides. What's 6 plus 4? 10. And then here, what are my measurements on my side? What would this give me? Plus? Minus 2. Be careful, those were negatives. So there's our answer. Any questions with that? Okay, flip it over. We're taking the tiles away. Okay, I think this one has a mistake too on some of y'all's if I give you the old paper on accident because we ran out. Okay, so again, first things first, we have to move our constant to the right. We have to move our C term to the right, yes? So what's my C term that needs to move here? The plus 1. How do I move it? Minus 1 on both sides. And that leaves me with x squared plus 8x equals 9. Now we're always going to rewrite it with those blanks after both sides because we have to add something to both sides to make it a perfect square. Okay, so we're just rewriting it with a blank and a blank. And this is our saying. Okay, I'm going to write it. Half it, square it, add it. Half it, square it, add it. How did we know how many x's to put on each side of our tiles? We would cut the middle term in half, right? We cut our b in half. So that's what half it means. What's half of my middle term? So 8 divided by 2 is 4. Now, this is x squared, so wouldn't this just be x? Because when we square it, it'd become x squared. So this comes here, positive 4. So we half it, and that's what goes inside of our parentheses squared. And then we square it. What's 4 squared? That's what we add. Half it, square it, add it. And when I add it, what's 9 plus 16? Yes. that's where we're stopping for today. So half it, square it, add it. Cool? Okay, so let's look at number 5. These go pretty quick. Is this one already set up for us? Yeah. Okay, so I already have my C on the right. Okay, so we have our B term. What's my B term? So what's half of 4? 2. So remember, that's what's going to go here. So x plus 2. And then I square it. What's 4 squared? Sorry, what's 2 squared? I kind of gave you the answer. Okay, it's 4. So I add 4 to both sides. And then what's 12 plus 4? That is the completed square. Yes, ma'am. Yeah, that's okay. Sorry. Okay, so looking at number 6, we're following our first step, which is move your constant to the right. What am I going to do? Plus 7 on both sides. So this is going to be 7 on the right side of the equal sign. And I know I'm going to plug it in to something that looks like this, right? So what's my B term here? 12. What's half of 12? So that's what I'm plugging in, positive 6. So we halved it. Now what do I do? Square it. What's 6 squared? Do not say 12. Huh? 36. I'm just glad y'all didn't say 12. Okay? Remember, 6 squared, if you need to type that in, you can. Nobody's going to be mad. Okay, remember that means 6 times 6, not 6 plus 6, or not 6 times 2. Okay, so then we add it. What's 7 plus 36? And if you need the calculator, please use it. It is 43. Any questions with that? Hanging on for dear life. Okay, what's different about 7, 8 versus 5 and 6? Yeah, our middle term's a negative, and that doesn't change how we do anything. Okay, and I'm going to show you the only difference here in just a second. So I know that I'm going to rewrite this. The C is already on the other side, so I'm going to rewrite it with my blanks. Everybody should have that written down. Okay, we're going to rewrite it with our blanks, and then I'm also going to go ahead and write it like this. And I'm going to take my B term, and I'm going to half it. What's half of negative 8? What kind of 4? Negative 4. So do you see the only difference is now my square is minus. That's the only difference the subtraction makes. Cool? Okay, so we half it. Now we square it. What's negative 4 squared? Not negative. Positive 16. Because 2 negatives make a positive. That's why. So it doesn't matter. No matter what, when you square it, it's going to be plus. That's why we put plus blank plus blank. And if what I do to one side, I have to do to the other. And then we add it, and that gives us 36. Good job. Okay, so last one together. Well, kind of. Okay, we're going to move our constant first. What do I need to do? Plus 10 on both sides. So then I'm going to get x squared minus 6x, and I'm going to go ahead and leave my space for whatever I'm adding. And I know I'm going to plug it into something like this. So I want y'all to try this one. Ready, go. Try it. Because 2 negatives makes a. So anytime you square something, positive or negative, it's going to be a positive. Okay, so what is half? -3. So half of our b term is -3, which goes here. And then we square it. What's -3 squared? +9. So we're going to put 9 and 9, and then we add it. What's 10 plus 9? 19. So there's our completing the square. Now, before I give you your practice, so we're done with notes, but I'm going to do 2 refreshers. So y'all have a test when? Wednesday. So the rest of today and tomorrow are going to be reviewing for your test. So we're going to do some completing the square on your practice, but we're also going to throw in the other 2 things we've learned this unit. Do y'all remember what that is? Quadratic formula, and then completing the square. So I'm going to do one example of both to kind of refresh y'all before I just throw a practice at y'all, because it's been some time since we've done either of them, okay? Yes? Okay, so look at this one. I'm just going to use the problems we already have on our paper. We're going to solve this one by square root method. Okay, do y'all remember with the square root method, you have to get whatever squared alone? Yes, well, my whole parentheses is squared. Is it alone? Yes, so when it's alone on the left side of the equal sign, that means I can go ahead and square root both sides, because the reason we have to square root is because what are we trying to get rid of? The squared, okay? Because I'm trying to get x by itself, and I can't do that until I get rid of the parentheses, which means I have to get rid of the squared. The opposite of squared is square root, so square root cancels the squared, and we're left with x minus 4. And then do y'all remember when you take the square root of a whole number, you have to have that plus and minus? Okay, so we have plus and minus, and if I take the square root of 36, I get a whole number 6. So do I have to do the factor tree? No. Is x by itself? No, so we're not done. What do I still need to do? Plus 4 on both sides, so plus 4, plus 4. Can I just type this in the calculator and say 10? No, because that's a positive and a -6. So what I want you to realize, you don't have to write it both ways, but you can type it both ways. So 4 plus 6 and 4 minus 6, we get -2 and 10. Does that help refresh y'all on square root method? Okay, so remember, the biggest thing is you have to get what's squared alone first. Yes? Okay. This one, I'm going to do a total different method. Now, could we solve the square root method? It actually would be easier, okay? But I'm going to refresh you on quadratic formula, so I'm not going to use the square root method. But square root method would be 100% easier, okay? I'm going to do quadratic formula. So I'm going to use the original equation before we moved anything to find my a, b, and c. What's my a? 1. Never letters, always numbers. Okay, what's my b? -6. And what's my c? -10. Remember, before we moved it, okay? Because we have to have it equal to 0 to use this method. Yes? Okay, so we use our quadratic formula, which is over there on the board. Do you ever have to memorize it? No, because it'll always be on your formula chart, okay? So we have x equals -b plus or minus. Do you remember what I call this? The skeleton. Because it's missing the guts. It does. It has the bones and no guts. Okay. And we're just going to plug in. What's b? -6. b is -6. What's a? 1. And what's c? -10. I know y'all are having so much fun. We're almost done. I know, I see you. Doing better than this guy. Okay. Do y'all remember that we simplify it in 3 different pieces? We can't just type the whole thing in our calculator. Okay, so we simplified this piece. What does that give me? What I just highlighted gives you 2. 2 negatives makes a. So we get +6. I don't know what I thought I heard then, sorry. What about 2 times 1 in the bottom? 2. And then we type just what's under the square root. Do we type square root? No, remember we call this our discriminant. I'm erasing all the things. So I'm going to type parentheses, -6, parentheses squared. A lot of people forget to square that. Please don't forget to square that. -4 times a times c. and I get 76. Is 76 a perfect square? Well, if you're like me, I lose track of them sometimes. So that gives me an ugly decimal. It's not a perfect square. I'm not going to keep, actually I will keep going. I know this gets gross, but it's not that bad. This is where you would factor tree it. 2 goes into 76 38 times. 2 goes into 38 19 times. And y'all, I do not have that memorized. I've just done it a million times today, so I remember today, but don't ask me tomorrow. Okay, so we have a pair of 2's, so I'm going to rewrite this as 6 plus or minus 2 root 19 over 2. 19 is prime, yeah. Now, do y'all remember I Heart Math to simplify? Yeah. Okay, what's 6 divided by 2? 3 plus or minus, what's 2 divided by 2? There's your answer. Okay, so that was a refresher. Okay,